Hello and welcome to Pulumi TV. This is a slightly different take on modern infrastructure this week as we're going to do it live. As always, I'm your host, David Flanagan, although you may know me from across the internet as rawkode, and today we're going to be taking a look at a Pulumi YAML support that was announced at Pulumi Up conference just last week. However, we're going to look at it with a twist and look at using Q as a language to provide said YAML. All right, joining me today, we have Q core team member, Paul Jolly. Hey man, how's it going?
Hi, David. Very well, thanks. So, glad to be on today. Thank you for having me on.
Always a pleasure. I could sit and talk to you all day.
That's kind.
There's always so much good stuff. Even just in our pre-segment video, there we were sitting talking about film scores and composers. So I was tempted to put that video back on for another 3 minutes and keep that going, but maybe later.
We'll try and get some Hans Zimmer on, feed that in later on as well.
Exactly. Yeah, I'm sure the copyright in that won't be too expensive. We'll start using
Yeah.
Hans Zimmer Pulumi TV scores. So for anyone who's not familiar with you and your work, could you just give us a bit of a TLDR on who Paul is and what you're up to?
Sure. Yeah. As the caption showed, I work on the Q core team, which means that I work closely with Marcel van Looyhausen, who created Q. Q is an open source project. We'll come on to talk a bit about what Q is in a second. That was developed by Marcel when he was at Google. Marcel's actually now left Google, and we are really making a thing of Q itself. And Q is really gaining in popularity in various different spaces, sort of known particularly as a configuration language, data and API language as well also. So the main focus for us on a day-to-day basis is actually trying to understand, okay, where does Q as an open source project need to go? And how can we make it as interesting and accessible to people in all the various different use cases where Q can be found and used. And we're going to talk through one of those today in the context, of, as you said, of, okay, how Q can interact with YAML, and in this case, how it can interact with Pulumi. So I look forward to that.
Awesome. Thank you for sharing. I guess we should, now talk about Q and what that means to people. I feel like all my people that I work with, all my colleagues at Pulumi are probably so fed up with me just going Q, 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 Q all the time. But it's such a powerful tool that I love that you said that it's really grown in popularity and it's been used in multiple spaces, but there's still a large number of people out there who just haven't come across it yet. And I hope that through a session like today, we can show people how powerful it is and how easy it is to get started. But for those people, can we just kind of give the what is Q in a kind of rough overview?
Yeah, absolutely. I think just before we dive into Q, there is that into what Q is itself. It's actually one of the main challenges for the open source project at the moment is to say, well, Q can be used in lots of different situations and is very powerful. The challenge for us is to make that as accessible to people as possible. So our plan is to say when they land on CUElang.org, which is the website, it should become immediately obvious to them wherever they are coming from as to why Q can be relevant for them. So Q is typically known as a configuration language, but it extends beyond that to also having capabilities in describing the structure of data and APIs as well. So when people think about using Q, they are typically thinking from like a configuration or data or API management perspective. And that's very, very broad though. So if you think about, there's one live stream that I did not too long ago where we actually used Q as the basis for describing GitHub Actions workflows. And in that scenario there, what we're using is Q as a way of describing the data structure that is our GitHub Actions workflow, but we're using the schema part of Q to help ensure that we are writing a valid workflow in the first place. Because if you're just writing YAML, you don't readily have that schema to hand. Whereas in Q, you're able to write the data as if it were just JSON, but validate that at the same time using the schema that is also defined in Q to ensure that you're actually writing valid configuration in that situation. So Q combines this nice thing of being able to have data and schema sitting alongside each other. And so really then you can say to yourself, well, okay, fine. In some situations, I actually want to describe something in more of a schema or API style, and that's where the schema capability of Q really comes in. In other situations, you say, well, I just want to write some data. And in that situation, so the data side of Q, if I could refer to it as that, is more powerful. And so there's lots of syntactic things within Q, the language, that make writing Q much nicer than YAML, for example, or much nicer than JSON. But it's not to say that Q then is we really hate YAML or we really hate JSON. Because actually we live in a world where all of these different encodings actually need to work together very closely. And so then that's another really key aspect of Q, is that it's not looking to replace JSON or to replace YAML. It's looking to work alongside them. And so we find that where people are using Q a lot, and I gave the GitHub Actions workflow example earlier on, is saying, well, GitHub Actions consumes YAML, but I actually choose to write my GitHub Actions workflows in Q because it's easier for me to validate that I'm writing a correct workflow. Then all I need to do is export my Q to YAML, and I can continue to interface with that system that already consumes YAML. So that's been one of the key stories that actually we've been hearing from people who are adopting Q, is that they don't actually need to go wholesale into Q. They don't need to rewrite systems to consume Q. They can continue to work with systems that consume JSON, YAML, and actually just introduce Q bit by bit to get small wins within their system, and then step back and say, well, hang on a second, this is actually giving us some real benefits here. Let's work out how we can make our Q support a bit more integrated and principled.
Awesome. I don't want to digress too much there, but I'm curious about the GitHub Actions stuff we were doing.
Yep.
I'm assuming
happy to chat about that some other time.
Well, yeah, because we all write our GitHub Actions workflows in YAML now, and some of them are getting quite beefy, and we're trying to find ways to make those smaller, composable, reusable, etc. I'm assuming you're just using the Q export and committing the .github YAML files into the repository. There's no way for GitHub itself to
correct
compile that.
Yeah, that's absolutely right, and we're happy to talk about that in detail another time, because I don't want to distract from what we're going to talk about today. But you just picked up on a really key word there, and that's reuse. And so something that's not fully implemented yet but is very high on the list is full package management support. So for those who are familiar with the Go ecosystem, where there are packages and the concept of remotely depending on remote code, so a package hosted by somebody else and owned by somebody else, that same concept will exist within Q as well. And that will be a first-class citizen of the language itself. And so there, the concept of, as an organization, perhaps building up reusable parts of your CI infrastructure or whatever configuration might be, you can then factor that into packages that can then be reused in different parts of the system. In a very simple way. And that's not to say that's impossible with other languages, but with Q, you've got all the benefits of Q, plus you've got a very good package management story to come with it. So that's something exciting we're working on right now.
Yeah, definitely. I hope that comes with a schema.QLang.org, where we can, like schema.org that has all these JSON schema repositories.
Yeah,
I'd love to see something like that for Q.
Yeah, it's super interesting actually, because those a lot of my understanding is that GitHub Actions, GitHub themselves don't actually own the JSON schema specification for the workflow specification that sits on schemastore.org. And that quite surprised me, because it sort of seems like there's a whole load of derivative benefits to them owning that, and that being the source of truth. Anyway, that sort of point aside, I completely agree with you. If these schemas do exist in the wild, and there can be a single source of truth that people can reference, they can make a part of their configuration ensure that it is consistent with that schema, and that there's a whole load of benefits that come from it. And this whole idea behind being able to compose large Q configurations and have them all be consistent, because they all are consistent with specific schemas, it is part of the Q story. So yes, I think we'll definitely see something like that in the future.
All right, last point of digression, and then we'll get back on track here. You should look into GitLab's CI system, which actually does provide a compiler flag to run a command on an object to generate the workflow, which is really cool. So I'm now, like, in my head, I'm like, I need to go play with that IQ, because that would be cool.
That's a rabbit hole I'll happily explore with you. Yes. Because to be fair, I have not looked at GitLab, excuse me. My focus has only been on GitHub, because the Q project itself uses Q in order to maintain the workflows for the Q projects that all run on GitHub CI. So yes, we should look at GitLab as well, because that's obviously a very big contender in this space too.
Yeah, I think they were one of the first organizations to provide CI/CD with a YAML interface, and I think they ran into a lot of these composable, reusable
Yep.
issues really early. And they were like, you know what, just generate your YAML with whatever you want, and here's a flag that you just tell it how to spell that YAML, which is cool. Anyway,
Feels
we're
like a
here.
good live stream episode, that one. Yep.
I know there's too many ideas, not enough time. That's the problem. But today we're going to take a look at Pulumi's YAML support and see how we can use Q to kind of build our own abstractions and like just like you were doing with the GitHub workflows, but allow people to describe their Pulumi and cloud resources, build functions, build definitions, all the Q logic, magic stuff, and make their Pulumi programs a little bit nicer. Because while YAML is simple and nice, if you've worked with it before, you know the schema and stuff like that. Doing abstractions, things like loops, like I mean, we've all used a YAML anchor at one point, and I don't think any of us have ever enjoyed using a YAML anchor, but the ability to reuse those is really cumbersome. And I think this is where Q comes in with its superpowers, and just once you learn the syntax and you get comfortable with it, you can do some really powerful stuff in very little code. And I'm hoping we can show off some of that today with Pulumi YAML. No pressure,
Yeah,
but that's where you come in. So.
Yeah, it was great to see the announcement for Pulumi YAML support. You'll talk a bit more about that, but I think again it speaks to that whole world of, well, actually, to have first-class Q support out of the gate would be, a step too far. But YAML is something that people are very familiar with, and so it meets people where they are right now. But this again is what Q is trying to do: say, well, let's meet people where they are in terms of the YAML space that they're operating in, and as you said, provide them kind of the nice syntactic things within the language that make it easier to use from a language perspective. But also then the key point is, from a Q perspective, is tooling. So how can we actually provide really useful tooling that helps the person who's writing Q to do useful stuff? And so language server support will be something that comes down the line as well, so that you have within the editor just that fully rich experience of completion, errors as you're typing, just pulling all that information up front so that you're just making less mistakes, or at least catching the mistakes earlier rather than later.
Yeah, I always tell people that's one of our missions at Pulumi, is to provide a rich editing and composing experience for all infrastructure and cloud resources. So yeah, definitely. And to loop that back to what you said about Q earlier, and that it's there to kind of interrupt and work with these other formats like JSON and YAML, right? Pulumi YAML means we have YAML, and Q can come in and give us constraints and validate and verify all of that for us, as well as providing the abstractions on top. So I think we've chatted a bit, and I'm sure we could chat for the rest of this session, but I would like to share my screen and start running through some of the Q examples that we have in the Pulumi YAML examples repository. So here we go. So if you want to check out Pulumi YAML, you can go to github.com/Pulumi/Pulumi-YAML. All the instructions are here. Nice, simple example. And what resonated with what you said there, Paul, is coming to developers where they are. Like, some people don't want to fall back to a programming language for simple infrastructure use cases. Managing GitHub orgs and teams or repositories, creating a single bucket with an ACL. Like, you don't often need to write, 60 lines of Go, 30 of which are error checking probably, and then some TypeScript, etc. Like, a YAML definition is enough for the basic case. And I think this is really cool. But what we want to look at is examples. And there are 3 here that I worked on. We have the using Q to generate a random string or integer using the Pulumi random package, deploying an AWS static web app, and then my favorite one, deploying a complete Kubernetes EKS cluster on AWS with Q. So I think we should probably start with the easy one first, right? All right, info.q. And this is it. It's not too dissimilar from YAML, right? And that's the selling point of Q.
Yeah, I mean, Q is a superset of JSON, and there's then the relationship between YAML and JSON that makes it sort of feel that all 3 are going to feel kind of similar. But then we sort of get down to some specific differences between them that makes some from a writing perspective and maintaining the language perspective a whole load easier. So I look forward to diving into those.
Okay, let's get a project started so we can see how this works. So in order to use Q with Pulumi, we have to create a new Pulumi project. From here, we can say show additional templates. Now there's no Q, I don't think so. No, I'm going to fix that. We're going to add Q to our templates library. But for today, we can just say that we want a new YAML.
Q all
And,
the things.
and we'll just like plain YAML. We don't need any cloud provider at the moment. We'll call this modern infrastructure Q. And this will be the random stack. And this is the smallest Pulumi program I've ever seen. A single YAML file with not a whole lot going on. Let's pop that open. Where's code going to open? Nobody knows. Yep, I can't see it. Oh, I bet you it's behind my live stream preview. Of course it is. There we go. Yes, I trust me. Okay. And this is it. The Pulumi YAML interface allows you to specify any configuration that is required. We can also have some variables that can be reused throughout our spec, but the most important stuff is here. So obviously we need to define some sort of resource, and then we can expose outputs that can be used with Pulumi stack references or even just the Pulumi stack output command if you need to be able to consume this in other tooling. Now, what I'm going to do is just copy this and create, we can call this anything. It actually doesn't really matter, but I'll stick with the convention for now, which is input.q. And if I run Pulumi up, nothing's going to happen at this moment because we've actually not told it how to do anything. So I can create a stack, but there's no resources.
And presumably at this point, it's using the YAML file. It doesn't know anything about the Q file that you've put in there at this stage.
Exactly. Got a keen eye, Paul. So at this stage, I mean, we could use Q export to actually not have a Pulumi.yaml inside this repository as well. We could just have this as a Pulumi.q, and that would work. We would have to use the Q tooling, which would be Q export, which will spit out JSON, although we can do that as a -o. I can't remember how to do the
out YAML.
Yeah. Out YAML. Thank you very much. And we get something which is very similar to what we're looking for. Now, of course, it's missing the metadata that we need for a Pulumi program, but of course, we could add that, and we could go down that road, and that would be great.
Yeah.
I tend to use the different approach. So when we have this runtime here, we can actually provide options to the runtime, and I'm going to make sure I don't mess this up. Yep. So this comes in like name, and then we can have options, and then we can have a compiler, which would be Q export. And what this tells Pulumi to do is that we are going to run this command before we run any Pulumi constructs, and that will tell us our configuration, our variables, our resources, and our outputs. Which means our Q export that we see here of this will be consumed by the Pulumi program. And hopefully, if I run Pulumi preview, we will see that this is now going to create a random password resource. Fingers crossed. Look at that. Nice, right?
Very nice.
Yeah. Now, I'm not sure what route I prefer. I think there's a part of me that's like, you know what? I just want my Pulumi programs to be a Pulumi.q and just have everything in there. And use Q export and pipe that to Pulumi up somehow. But being able to specify the runtime and the Pulumi configuration is also quite nice, because then it means anyone can really come to this project and just run Pulumi preview and Pulumi up without having to know what the runtime is.
Yeah, I think as a starting point, this is an excellent starting point, right? From a DX developer experience perspective, there might well be, now that you've got this in place, you'll be able to stand back from it after 10 or 20 iterations of actually doing this and think, actually, what we want people to be able to do is X, right? And as you were typing the YAML there, I thought to myself, well, what you really need there is a schema against which you can know what is actually valid. And again, just to sort of bring in the Q angle there, right? That is what so there is a schema against which people will be writing a lot of the time. And so if you do have, if you are able to get to a situation where Q is then your first class support, and then we have things like the language server that come into play as well, you'll just be able to open a Q file, that the context will be clear, and so the schema against which you're writing will be clear at that point, so you will have all the completion, etc., that you want. So getting back to your point about making that experience a delightful one, that's probably where we want to end up, but how we actually get there, I think, is sort of the journey you're looking to explore here. I think this is a great start.
Awesome. Well, I don't think we really need to run the Pulumi up on this. You're happy, you can see the preview, and it does what we expect, right?
Yep.
Cool. I mean, I promise you, it works. It definitely works. So we'll spin up one of the more complicated examples. The random one's not that interesting. What I do want to point out for the Pulumi people in the audience is that we didn't register the random provider. That was all calculated by the Pulumi runtime. That's something that's new, or at least an improvement that was made for YAML support. Because typically what happens is if we have a Go project, then our go.mod tells us all the providers that we need. If we have a TypeScript or JavaScript project, we have a package.json. All of our languages actually describe the dependencies through a file, which we don't have with YAML. So the engineers actually built some magic provider detection and plugin installation all into it. So that, in fact, we could jump over to here. Hope I'm not getting too confident now, but if we go to the Q static web app, this uses Azure native resources, and we could actually copy this queue into our queue, and the Pulumi runtime would detect that we're now using Azure, download the binary if I don't have it, and we'd have a working Azure project, which I think is quite nice as well. Like that plugin auto discovery is very clever.
That's very nice. Yep.
No,
I'm learning a lot here about Pulumi because I'm very much a Pulumi newbie. So I'll be asking questions along the way. Hopefully, my questions aren't too slow for the audience.
Well, let's go to the good example. Mostly because I don't have an Azure credentials on my machine right now, and I don't want to have to try and do that live because I've never used Azure. So we'll just use QEKS. So this was the fun demo that I worked on. I was like, okay, how can we spin up a Kubernetes cluster with Q? So, and I went down a different route. I actually used a Q.mod for this, so that we could provide packages that could be consumed, which I thought was quite cool because in my head, and maybe this loops back to what you were talking about with like the package manager support for Q, and maybe there being a registry, but there's no reason I couldn't build out an entire repository or libraries of abstractions built on top of GCP, AWS, Azure, Cloudflare, etc. And people could just consume and use them, which I think is really powerful.
Yeah, absolutely. That's exactly what the first class package management support will enable. Just as today, if you're writing a Go program and you find yourself writing code that actually sits nicely within a package that you want to share with others, exactly the same would apply from a configuration perspective as well. And so that's that element of reuse coming in as well. And so quite what those packages of reuse look like, I guess people will learn along the way, actually, this is a nice level of reuse here, or this is the pattern that we should follow when we're trying to encourage reuse. So I think a lot of those things will become clearer with time, but that's the direction that we're traveling with package management support.
Awesome. And that'll be ready next week?
I think it's 2 weeks time.
2 weeks.
Yeah. It's high on the list. It's one of those things where, as you said earlier on, there's too many ideas and too little time, but we're fixing that. So
definitely. All right, let's do this one step at a time so we can see it fail, and then you can kind of walk us through maybe some of the Q things that are happening here.
Sure.
So we'll leave this as is. We'll blow away this, and then we'll kind of run through this. So we have a resources definition, which hopefully now we're comfortable with, and then we have two resource names, one rawkode, and then one of my colleagues' handle, which is stack72. So here, what we're saying is rawkode is something called an EKS.EKS cluster. Do you want to dive into what we're looking at here, or do you want me to throw my 2 cents at it?
No, please, if you want to start, because here I actually had a question, and this will appear sort of like quite a naive question for those who are more familiar with Pulumi. So this resources block that we're the resources struct, if I can call it that we're looking at here, it is presumably just anything can go in there, except to say that it's like a map from some string key name to, on the right hand side, then a value that describes the instance that we want the resource we want created in this situation.
Exactly. The resources is a map, and that map is a string ID, which is the name of the resource, and then we can have any valid resource type or description on the right hand side. So rawkode is my resource name, and then I'm saying that I want an EKS cluster.
And so EKS cluster here is something that you've defined, and the hash definition there indicates that it's a definition, and we can come on to that in a second. But you're essentially saying, is the EKS cluster something you're imagining that would ultimately be in a sort of a package more centrally, where someone who would be responsible for maintaining that definition?
Yeah, this is just one that I provided to show people that using Q, we can have packages. We can build our own definitions, which can be reused. Because what we see in Pulumi land, at least, is that when people are building platforms, is that the platform engineering team will actually determine what that platform looks like, and they expose a small interface of options or configuration that can tweak the way that works. Like, it's very rare the development team would just use the raw EKS or JKE APIs, because the platform team is like, oh no, we've got sensible defaults. Like, we want to deploy monitoring, observability, logging, tracing, all these other cool things. And that's all I'm doing here is I'm saying, like, in our organization, oh, there's my fire alarm. I'll just mute for.
We need some Hans Zimmer music at this point.
All right. It's just a test every Wednesday. In fact, I should remember that, 11:30 on a Wednesday. Yeah, so this is just what I'm describing to be an EKS cluster. And we can take a look at this, and we can compare that to what, I think there's another EKS example in the repository that works directly with the definition, and we can see how those compare.
So I think the one thing that I would point out at this stage is that, given the file we're looking at here, resource is effectively a specification of, from like the data side, if you like, of what resources do we actually want to be created. And what you're looking to do with rawkode and stack 72 there is saying, for these resources, I'm trying to constrain or enforce that they follow some sort of structure here. And that's the schema part of Q coming in. So the definition side here is that's the use of EKS cluster here constrains the rawkode field to actually be of a certain structure. And as you're seeing for the use of stack 72 there, you're saying, well, it's an EKS cluster, and I'm going to give you some more information about that specific cluster there. But the use of definitions in this way is very much like a sort of a validator type approach, where you're saying, well, it's going to help you prevent any typos. It's going to help ensure that the types of certain fields are correct. So, for example, max size, if that were specified as a string, assuming you've specified your definition as such, it would catch that and flag that to you early, as opposed to if this were not validated in any sort of way by a schema, you'd make that mistake, and only when you subsequently came to actually try and apply that configuration would you find out about it. So this is how the schema part of the queue and data sitting alongside each other work so nicely, is that you're seamlessly using the two together here in order to make the writing of your configuration much easier.
Yeah, I'll add one thing that you missed, but by using the definition, the constraints is really cool, of course. But the defaulting as well. Like, I actually wanted to provide a whole bunch of defaults for an EKS cluster that can be overridden, but they're not a default in the AWS API, so we can make them a default in our definition.
Excellent point. Yep.
We have a question, so let's pop that on the screen.
Oh, great! I can't see quite. I'm probably looking at totally the wrong thing, so where I don't know where to look for the questions.
It's all right. We got a question from Twaza. Whose name is annoyingly hidden. Oh no, it's there. It's just on the right hand side. Weird. Sorry, I'm a Pulumi newbie and have never used Q. That's all right. We hope this session helps you. But they're curious. Does Q can it be applicable like policy as code mechanism? Cool question.
Yeah, so I think if I've understood the question correctly, and please tell me if I haven't. The idea, my understanding of the question is as follows: can Q be used as a means of effectively specifying policy? And the answer to that is absolutely. That is one of the key things with Q. So whereas let's just imagine David's writing this configuration here, but actually another team wants to enforce some constraints over maybe the resources that are being specified here. I'll just sort of wave my hands as to how this is actually implemented within Pulumi. But the idea behind Q is that you can combine and compose Q from different sources, and then that result should sort of be a consistent validation of all of that Q combined. And so this is the composable nature of Q. And so where like a cross-cutting concern like policy, where you might have multiple teams, in fact, wanting to specify constraints on the resources that you're specifying here, all of that Q would magically get combined together in some way, shape, or form. And assuming it validates, then all those policies would by definition be satisfied. And David, you'd be able to create your resources using Pulumi Up. So yes, Q can be used as a policy specification language, and we're looking to make some improvements to the language to make that easier. And it would sit very nicely and fit side by exactly this kind of usage that David has here. And David wouldn't even need to worry about it. That policy is like a concern or an aspect that comes in from somewhere else entirely.
Nice.
Hopefully I understood the question correctly.
I think you did. That was my understanding as well. So
great.
Okay, so yeah, we have a definition. Now we don't know what that is yet, and that's okay. And then we have another definition, only this time we're using the ampersand syntax and we're passing in something else, which is it fair to say that acts as an overlay? Would that be the correct syntax, or would you describe it some other way?
Yeah, overlay is slightly, it sort of gives an idea that of sort of inheritance where there isn't actually inheritance. So this is actually where the strict term for it is unifying, where you're combining these two together. And what must be the case is where you're unifying here is that the data you've passed in that struct there, so where you've got passed in the properties, that struct literal there, that must be able to combine with, for want of a better phrase, the description, excuse me, not the description, the definition that is EKS cluster. So it might actually be helpful to open up that definition here so we can see how this sort of combining actually happens to ensure that there is then a consistent result.
Okay, well let's do this one stage at a time.
Sure, yep.
So if we run Q export YAML, it's going to fail because we don't actually have this package yet. So in order to make this work, we have to run a qmod init. Is that right? Yeah. Which creates our q.mod directory, and then just like we have in this example, we can then create our AWS package.
Yes, I think what you'll also want to do is there, having done the qmod init, if you just open the q.mod in a second, I'll let you create this for starters. If you open the module.q, you'll see that it's not given the module any path there. And so you'll need to actually put in there the path, which if you just jump back to the GitHub code that you had, yes, exactly, you'll need that path in there.
And that's how Q module resolution works for now, right?
Yep. So there's effectively what you're declaring here with the q.mod is you're saying, much like in the Go world, all of my code now lives within a module, and you've given that module a path. And that means that packages that live within that module, and this maps exactly to the Go concept as well, can be addressed by that module path plus any subdirectory within which that Q code may exist. So here, this then allows you to reference, as you had within infra.q, if you just go to jump to infra.q now, that allows that import statement at the top there to actually resolve. So the module itself within the main module within which we're working is examples.pulumi.com/YAML-EKS. And you just created the AWS subdirectory within that, which then allows us to reference the AWS package within that. And what you've then specifically done is within aws.q, you've got,
It should be eks.q, right?
It doesn't actually matter, because the only thing that actually matters within there is the package clause at the top, which I'm assuming is EKS.
There we go.
Yeah. So what you've done there is the reason you're having to specify EKS in the import statement is that the package name you've given in that file does not match the directory within which it's contained. So if you wanted it to be just the import path to just be examples.pulumi.com/YAML-EKS/AWS, you would just need to change the package clause within aws.q to be AWS and not EKS. But this, because the thing here is that what we are supporting Q is that you can have multiple packages in a directory. And so what you're doing is you're specifically referencing the EKS package that exists within the AWS directory. For normal use cases, it may just be easier to make the package in that situation AWS, and then you don't need to specify exactly which package within
I guess it depends how many different definitions you're going to have at that level and whether it makes sense to have some sort of logical grouping via sub-packages.
Indeed, or whether you actually just want sub-packages, indeed. So you might actually say, having a subdirectory for EKS might be the best way to structure things. But again, this is what I meant earlier on, is in terms of what that level of reuse looks like and how it's best structured. It is going to be a learning exercise for people in the Q space, as it is with even Go code, for example. How to actually structure a good Go API is not a solved problem in and of itself.
All right. And for people that want to be able to reuse these things in lieu of the Q package manager right now, I believe the easiest way for them to do that is just to have a repository that can be cloned to the package directory that has all of their common definitions.
Yeah, so that then, if you put it precisely so, and then that resolution happens within the PKG directory, it's almost like a Go vendor. It's like a vendoring your code into the PKG directory. The resolution happens following a directory structure that matches the module and package path at that point.
This is just what I love about Q. Like, I'm probably going to be the biggest user of Pulumi YAML, and I'm never going to write a line of YAML. Like, I think that is really cool.
Yeah.
All right, let's okay, we've made this resolved now. This should Q export, and it should Pulumi up. There we go. So we can run Pulumi export if we want, and we can also run a Pulumi preview. And let's see what we get. Doing a bit of thinking.
So this is presumably where it's resolving the doing that detection as well of what resources it actually requires in this situation.
Yeah,
as you were saying earlier on.
One bit of configuration to make that happy, which just goes into my pulumi.yaml here, and we can run preview again. With AWS, you always need the region, and I always forget. So
okay,
this looks much nicer.
Wow.
I mean, I could remove the stack one, right? And we could just have the rawkode EKS cluster. But in literally 1 or 2 lines, depending on how many overrides or values you need to inject into the definition, we can get complete Kubernetes EKS clusters with instance roles, instance profiles, security groups, and security group roles. Now that's pretty cool. I'm happy with that.
Very nice.
Yeah. The definition for this, which we looked at very briefly, right now it's not doing anything too fancy. Of course, we could add more and more to this, but we're just making. I'm using this for defaulting and constraints. So I'm saying that if you don't provide a instance type, then we're going to default, which is the star in Q, to a T2.medium, but we also accept a T3.medium. So I'm actually applying constraints. I'm not giving them carte blanche here. I'm saying we're on this cluster, you can only use T2s or T3 mediums, and that is all.
Yeah. And just relating it back to the question that somebody asked about Q being used as policy, if there was like a further constraint that somebody wanted to specify as a policy that the instant types could only be t2.medium and not t3.medium. That could be specified as policy. And again, waving our hands to sort of imagine how that policy would actually be consumed at that point. That would further constrain the valid instant types at that point and prevent you from actually specifying t3.medium if you wanted to.
Yeah. Then we have some default values for desired capacity and min and max. Only here we do accept any integer value, so of course you can configure that however you need. And we have, well, I'm not going to run it because EKS clusters can take up above 20 minutes to run. But we can see from the preview that we're getting everything that we required. So I'm pretty happy with that.
Might just be worth pointing out that because you've used a definition there in this situation, you can't add fields that actually are invalid in your infra.q.
So we break it?
Yeah, break it with a rawkode field or something like that.
I am here, lol. There.
Yep.
And
so
Q
then
format, nice.
Q format, I was just about to say. And then if you run your Q export again, that should actually break, right?
Yep. Field not allowed.
Yeah. So that's the schema side of Q being combined with the data side, right? In order to help that experience. Yeah, there we go. There would be another validation rule.
Yeah, another validation. But when we run, we get conflicting values. You know, we expect a T2 medium or T3 medium, and we send a T4 extra large. So.
Yep. So the idea behind the language server will be that instead of having to run Q export in this scenario, you would see all of this within the editor. So you would have a squiggly red line under T4.extra large. You would get code completion within the properties struct there to know what things you could actually specify, etc., etc. Imagine sort of a programming language where there is language server support. The same will then apply for Q as well, because it will know the schema that you're actually trying to write against here.
Yeah, I'm looking forward to that. That's going to be pretty powerful stuff. So,
it will.
All right. Is there anything else you want to cover from this example?
No, I think this is a really good starting point for people in terms of understanding how Q can be used. You saw some of the language syntax benefits there of using Q versus YAML or JSON, if that's something that you prefer. We saw some of the reuse components via the importing of packages. We saw some of the schema and validation aspects via the use of definitions. And you showed seamless integration with the new YAML support in Pulumi, which shows how I think Q can interact really well with existing systems that consume encodings like YAML and JSON, etc. So I think that was really good.
Yeah, I'm really excited to start shipping abstractions for people to kind of make working with this YAML a lot easier and allow them to use Q and definitions and just really have that, improving that experience. Like the YAML interface is great for people that just want to spin up something fast, but for the more complex use case, we really need to leverage the power of Q, just as we've kind of shown here. The EKS one is a simple and contrived example for now, but there's going to be lots more cool stuff coming here for sure. So
I think you made a really interesting point about why YAML is a benefit over sort of programming languages being used like TypeScript, etc. I think that Pulumi support is that if you allow people to use YAML, you don't make any judgments on how they will actually compose that configuration as part of wider configurations they will have within their organization. And if you just allow them to use YAML, then it's very easy for them to actually have what you can say, well, this is just part of a much wider configuration we have within our organization. And this piece is then fed into Pulumi here. And that's again where Q can, where Q can come in, is that trying to considering that you should view your configuration as one big thing is absolutely something that Q can achieve. And so it's not clear how something like TypeScript would necessarily compose within a larger configuration in that situation. So I think the Pulumi YAML support in this respect is like a really strong thing.
Awesome. Well, I want to say thank you for joining me and sharing your wisdom with us today. It's been fun. I'm hoping we can do more stuff with Pulumi and Q in the future, and I'll definitely be inviting you back. So just try not to ignore all my emails. That would be very kind of you.
Thank you for having me on, and I'm slightly daunted but excited by all the other rabbit holes that we suggested we might have to explore. So
yeah, there's so much stuff we could have fun with here. So I think it's going to be a whole lot of fun. But we'll be back in the future. But for today,
David, thanks very much.
Thank you again, and I'll see you again soon.